Well, hello there, everybody. Welcome to Cam 130 at SCC. Hope everyone's doing okay. I am Dr. Fred. Um, I'll be the instructor for the next 16 weeks. Okay. Got a couple more people here. Let me let them in. Okay. Well, I hope everyone's doing okay. Being safe out there. It's a little crazy. We're going to be talking about a lot of stuff today, and it's pretty extensive. Our Friday SEC class goes from 1 o'clock, obviously, to 3:40, and that it's a tough 3 hours almost to get across, especially online. So we're going to do my best. We're going to take some breaks in between, so you don't get too bored. I try not to bore you too much. Okay. But first, before we do anything, I need to take a roll call. So what I'm going to do is I'm going to get onto my roster, call your name, and if you will, in the chat, type your name in, your full name in the chat, because this is being recorded and I get a hard copy of that. Okay. So let me call your name first. Okay. So, all right. Now, if I kill your name, my apologies early. And don't try to do it. It's not on purpose. Okay. I have Leah Alton. Are you here today? Got you. All right. How about no problem, Kathleen. Brigitta Anderson. Are you here today? I don't see her. One more time. Birgitta Anderson. Nope. Okay. How about it's tough to see. I need a microscope here to see the canvas, but it's either Jeff or Jet. Jett. Is that correct? Yeah, there you go. We're good. Catalina Caballero. Catalina. Okay. Right. And whoa, gotta let her in. How about Anna? Cedar Storm. Anna Cedar Storm. I hope everybody can hear me. I was having some technical problems earlier, but I had to switch over to a different kind of mic. Okay, Hannah, yes, you're there. Sorry. Erica Daniel, you here today? Erika. Okay, got it. Thank you. Madison Davis. Madison, you here today? Type your name in, please. All right. No Madison Davis. Okay, what about Montana? Are you here today, Montana? No. Iankin, okay. Montana, not here. Okay, how about Jalen Fight, I believe. Jalen, are you here? I don't see you. Oh, there you are. Okay, got you. How about Nick? Nick, you here? Nick's here, got you. I see, okay, Bridget, got you, Bridgetta. And how about Cade, Cade? Fredrickson, okay, there you go. Was that Jesus or Jesus? Garcia? Jessup. One more. Okay, Garcia. Okay, how about Thomas? Thomas Gordon, I think I saw you. There you are. Type your name in, please. Gotcha. And Eric Huber. Eric, there you go. Thank you. Katie Cassinian. Cassian. Katie with a K-A-T-E-T-Y, excuse me. No, Katie. Oh, there you are. Okay, got you. Isra Kinwaba. Isra, there you go. And M-A-E-V-E, is that pronounced May? Futsal? Okay, gotcha. Alexandra. Alexandra, there you are, I see you. Okay, I see one more coming in. Caballero's in to see. Okay, and that was Alexandra, then Amanda, excuse me. Amanda, you here? Amanda Melek. I got it. Okay, see her. Amanda. Black. What about Eva? I saw Eva come in. There you are. You're on top of the screen there, Eva. And I have, is that Kilben? Right. Right. K-H-E-L-B-E-N. Right. R-E-I-C-H. There you go. I see it. Angeline Sigala. Angeline, are you here? There you go. Okay. How about Abby? Salamantes, got it. And Angela Turney. Angela. Okay, there we go. Christina Vandrill. Christina, got you. And one last one. What I have is Sarah. Ooh, Zoro Fetchien. That's you, Sarah. All right. Now, my apologies if I chopped up your name. So the people I do not have is Madison, Montana, Jesus, Garcia, and Amanda. Correct me if I'm wrong.
Montana's here.
Montana's here. All right. You type your name in the chat, please.
I did.
Have,
I'll do
oh,
it
you
again.
did? Okay,
I'll
no
do it
problem.
again.
Okay, thank you. I appreciate it. Okay, well, it's good. The reason we're going to do this, I got something new going on with respect to something has to do registration. If you're not here for the first class, everybody, not only here at SCC, but all through Maricopa, we have to drop you because of something that had to do with refund if you want to drop your class. Anyway, so like I said, if you came in late, welcome aboard. We're gonna. I get the privilege of talking about chemistry. Now, I hope you had a minute to read my intro. I kind of bring a little bit of different perspective with respect to chemistry. I come from industry. I've been teaching part-time now for a while. So I worked in industry and process and product improvement. I'm an Arizona boy. I'm originally from a little town east of here called Superior. I left about 100 years ago, came back, and I'm like, whoa. When I left, 60 wasn't even here. So that's how long ago I left. Well, it is almost 100 years ago, 1970, so it'll be half a century ago, pretty close. Okay, well, we've done checking the roster, making sure everything's up to date here. Now, here's the thing. I've been asked this a lot of times during this online. Do I have to attend lecture? Okay. Well, I look at it this way. This on live lecture part is like being on campus, except we're doing the Zoom. Now, you answer that question if we were on campus, whether you had to come here, every week. That's on you. I'm going to be here every Friday until May. With respect to the labs, because in your case, the labs are incorporated into the lecture room, those are on your time, and they begin next week, and there's 11 labs. And we'll get more detail about that here in a bit. And so that's basically, you go up there, you knock it out, you're done. That's a done deal. You might make room for about 2 or 3 hours because you're looking at videos, you're looking at a variety of different things. So we try to emulate it as much as possible as if it was a real lab, given the online situation that we have. So they'll be spending some time there. We have 16 chapters. Now, the last chapter it deals with gases, very short. Normally what happens is at the end of the semester, we have about maybe 1 day of what I call class time, your time, because we have finished ahead. And so during that time period, toward the end of the semester, I'll be here, but it's open as far as questions and so forth. Now, I teach 2 campuses. I teach at a GCC and here. And what I've done is and we're teaching the same class, 1 Chem 130. And we are governed by Maricopa's policy about what parameters, what we talk about. And so regardless if you're at GCC or wherever community college you're at, you have to touch upon the same topics. And so for my 3 sections, we are using everything the same textbook. Even the labs are similar. Okay, I try to incorporate everything together. So that's kind of an advantage for you, I think, because I can tell you right now, I teach Tuesday and Thursday Zoom sessions, 1 o'clock and 4:15, and that's for GCC. You are more than welcome. You got the same Zoom link that they do to jump in there. If you need more help, you need to go over some more stuff or listen to what I got to say again. Okay. So you're more than welcome to go there. Sometimes I understand you work, you got multiple classes, you can't make it here. I will record the recordings here. I'll have more about that in a second. You're welcome to view those at your leisure, but you're more than welcome to come Tuesday and Thursday, because what I try to do for all 3 sections is try to maintain the same chapter. Yours is a little bit more challenging because we meet once a week, but you're pretty much within 5-6 slides of my PowerPoints. So feel free to get help there, to get more information, because here's the thing about this chemistry class. If you have a challenge in the first few chapters, it's going to be a challenge at the end, okay? Because we need to, like most classes, we build on what we learn, and toward the end, I'm going to attempt to bring everything together for you, okay? Right now, it's going to look like it's all foreign, but I'm going to try to bring it all together so it kind of makes sense. And being that I've been in industry and I worked with a variety of people with respect to background in chemistry, from the layperson to the engineers, I tend to use a lot of analogies with real life situations that you deal with every day and may not note it and say, hey, this is chemistry, because chemistry is all around you. I'm not saying that this is the most important class in your life, far from it. I'm saying that every aspect of your life, chemistry is involved. And what's amazing, which kind of got me going with chemistry, is we're going to talk about this, is electrons. Those little crazy things what really got me into it. Now, I hear a lot of, well, I can't do the math. I'm here to tell you something. If you can add, subtract, multiply, and divide in a calculator, you're good. We're not doing differential equations. We're not doing calculus. We're not doing complicated matrix algebra. We'll do a little bit of algebra, okay, but very general, so nothing complicated. So if you can do that, you got it. If you can calculate, if you're working right now and you say, I'm working $50 an hour, and you can calculate, okay, how much money do I make after 100 hours? And you can calculate that, you can calculate the chemistry, the math in chemistry, okay? Or vice versa. If you're working $50 an hour and you need to figure out how many days you need to work to make $5,000, boom, you can do the math here. Okay, so there's nothing complicated. Chemistry, yes, it can be complicated, but I think a lot of it is the way it's presented. FYI, my first chemistry class I took 100 years ago, I totally bombed it. Big F, like my letter, my first name. I'm like, whoa, okay. Here I am with a doctorate in chemistry. Figure that out. And it had to do a lot with the way it was presented. Yes, there is a lot of facts. You can memorize, okay, and do this and that. But I realize that a lot of you you're not going to be chemists. I think about half of you might be nursing students, right? Maybe about part. Could be some engineers, Yes, I'm not going to make you chemists, but I hope that I can help you analyze problems and come up with solutions based on what you have. Problem solving, okay? Critical thinking. Those are things that you're going to use whatever field you're going to take or whatever you do at the end of your career. Education, it's important. You're here for a reason. I guarantee you're going to continue your education. I'm still learning. My undergraduate, it was 1982. None of you were born then. Okay? I think maybe your parents weren't born. 82, my doctor was in 93. And once I got that piece of paper, things didn't just stop and magically, I knew all the chemistry in the world. No, you always are learning, and you have to learn. What I say, from my perspective, is love to learn. Because you start learning things, and when you learn things because you like learning things, that information gets stuck someplace in your head that you can access it, rather than learn things you hate and it's temporary memory and you lose it in a couple of weeks or a day. Anyway, that's what I hope to help you with at the end of September. I'm here to help you. Okay, I will do everything I can to assist you to finish your dream of whatever you want to do. Okay, but I can't do it for you. I got a lot of resources to help you, but it's on you. The only person that can do this is that person you see in the mirror. Okay, just like Michael Jackson said. All right, let's talk about the syllabus for a little bit. And let me call that up because there are some aspects about the syllabus, and we're going to talk about this. And we're going to go after the syllabus. We're going to go into the Canvas course to show you some information. And then if there are no questions, we're going to jump right into chapter 1. Okay. So by now, all of you hopefully have read or looked at the syllabus. Okay. It's sitting right here. I'm sharing my screen with you. Start dates today. The last day is the 14th. That means that every assignment, now all assignments, I can tell you this right now, all assignments with the exception of exams, everything has a due date, okay? Everything has a due date, but and the exams are given as specific days, okay? Those don't change, okay? Now, the due dates. Now, the homework, it can change with respect to due dates because I will not make something due if we haven't completed an lecture, okay? And so if I'm not completed that chapter and the due date's like today, well, no, it's not due today. I'm not done with the chapter. I'm going to give you 2 or 3 days after I'm done with a particular chapter to make the homework due. Now, all homework, all the activities will be open until the 14th. But if they're past the due date, there will be a penalty involved with that. Okay. But I'll get to that in a second. All right. So here's my information, my name, so on and so forth. Now, email. To contact me, the number one method is through Canvas email. And I repeat that. That's our official communication mode to communicate between instructor and student. Now, that email on Canvas, I have it tapped into my phone, so I can 9 times out of 10 respond to you pretty quick. The other email, my EDU email, I don't monitor it very often, okay? And so if you send me something there, you may not get a quick response. So stick to the Canvas email so I can get back to you if possible. Okay, Amanda, she's here. 1 second. And in case Canvas breaks down, which it does happen occasionally, then yes, then we do the EDU. All right. Office location, obviously, I'm going to have some office times. I haven't set that up yet, but I'll be announced to you. But it will be through the Zoom, and obviously you're here because you got the link. Brief description of the course, FYI. Now, all the chemistry for Chem 130 throughout all the Maricopa campuses, we must talk about 29 subject matters, topics, I should say. And so we're going to do that. We're going to hit on all these 29 different topics throughout the semester. And this is true for whatever campus you're at. Okay, your textbooks, you don't have to buy a textbook, okay? All your textbook is free. It's in PDF format. When we get into Canvas, I will show you where it's at in case you have not found it yet. Everything you need will be on Canvas. Okay, so no textbook. But if you want an additional textbook, you can go to this link here, and some of these OER, what's called OER textbooks, or they're free, open resource. These are textbooks written by people for no price, no cost, or very low cost. So you're free to go there. Yeah, you will need a calculator, but trust me, you don't need a calculator that does fancy stuff. You need add, subtract, multiply, divide, and you need you need it to do what's called scientific notation, okay? All that is a shorthand way to write humongous numbers, because you will be working with big, giant numbers or extremely tiny, tiny numbers. And normally, for example, a number 6.02 times 10 to the 23rd, take that 6.02 and move the decimal point over to the right 23 times. That's how big the number is, okay? And if you try to type that into a calculator that doesn't have scientific notation, it won't accept it. So just make sure your calculator has scientific notation. Your Windows, if you're off the computer, your Windows program, Windows 10 does offer a calculator with a scientific notation function, FYI. Okay, we'll be using Canvas. There's course policies. Now, what about the grading? Well, here's the assignments, okay? You're going to have homework online, okay? There's a total of 15 homeworks per chapter. They're very short. They're about 10 points. The lowest 3 will be dropped of those 15, okay? Lowest 3. Now, they all will have a due date, but they won't be due until after we're done with that chapter. Now, after that due date, they're still open for you to complete. However, there is a penalty. Canvas will calculate a 10% per day penalty until you reach the 50% mark, which is 5 days. So after 5 days, you're at the 50% mark. What does that mean? That means on the 6th day, if you attempt the homework, then if that homework was worth 10 points, the most you could get would be 5 points, okay? Now, some people say, well, I missed it. I've already passed the 6th day. What's the point? Well, it's up to you, but you know what? Some points is better than 0, okay? But all the assignments, the activities, and the homework will be available until the 14th, but with the penalty once they're past their due date. Any questions about that? Okay. This part here, read and read, the homework on for this class is posted on Canvas. I'm going to go to the website in a bit, and I'll show you where you can get additional resource, additional information, and additional homework examples that you can use as a resource, okay? Because all of them are all very similar to what you find on your Canvas online homework and exams. There's 10 activities. Some activities call for you to download a sheet, a data sheet, or write something on a paper and then take a picture and then upload it back into the assignment so I can view it. Okay. Now, the preferred format is a PDF format. But if push comes to shove, if you have to send a JPEG, I will accept the JPEG. Okay, no, not a problem. And when you submit anything, there are some phones, and I haven't figured which one it is, but some phones out there, when you create an image, they have a HEIC extension. I want to say it's the Galaxy phones, maybe I could be wrong, but there's been some students who uploaded that. I can't open that format. So make sure it's a specific JPEG, what else? PNG I could do, but preferably a PDF, and there's no question about submitting it. If you have a problem, yes, and we got a quick question. Yes, there are, Caitlin says the Genius S-Scan is free for PDF scanning, and you can do it on your iPhone notes with a picture button. That is correct. Okay. I'm more an Android person, so I don't know much about the iPhone. When I have questions on that, I direct it to my partner. She's an iPhone. I got my personal reasons why I don't like Apple. Wait, that goes back 100 years. All right. So there's activities. And again, they also have a due date and they have a penalty also. Now, SCC has, the department has what's called a nomenclature exam. And what that is, that's worth about 10% of your grade. What a nomenclature exam is an exam that either gives you a structure, a formula, or a name, and you have to either, if you're given the formula, you have to give it a name. If you're given a name, you have to select the formula. It's a nomenclature, name that compound. SCC requires that a student pass that with an 80%. It's like 20 questions. You have multiple attempts to do it, okay? And if you do it within the constraints there, you receive a 1% bonus. If you do it before the end of, we got one more. And, okay. If you finish it and complete it, get the 80% before the end of the 11th week, we'll give you a 1% bonus. And then after the 14th week, you get a 2% deduction. Okay, so the maximum you could get is 16. So keep that in mind. Do it as many times as you want. What happens is right now there's no points in there, but about a third way through the semester, if you haven't done it, I will insert a 0 in there so you can see the effect on your grade. And it's quite drastic. If you are on the border, 10% will kick you out of the border and drop you down. Okay. All right. Any questions of that? So you got online activity, you got nomenclature exam. All right, let's do. Now we have 5 lecture exams, okay, which are broken up per chapter. And then we have a comprehensive final exam. The lecture exams are worth 30% of overall grade, and the final exam is worth 15%. Okay. Now, if you miss an exam, and if you know ahead of time that you will miss a exam date, get with me immediately. We can make arrangements for you to take it in alternative time. Okay. If you miss it, once the exam starts, it starts and it ends. It will be open from like 7 in the morning to about 11 p.m., 10 p.m. that evening. Okay. So that's your window. That's your window to take that exam. If you miss it, well, you missed it. I can't make it up, especially if you didn't make arrangements with me beforehand. So one option I do have is that I can take the final exam score and substitute any of the 5 missed exams. If you miss the second one, I can't do that. I can only do that for one. Okay. Yes, it is. The final exam, I have some leadway with respect to exam because this exam is being taken multiple places and I got to coordinate that. But if the exams 1 through 5, I can go like 2 days forward, back, and 2 days, 2 days either way, one direction. The same with the final exam. So if you know ahead of time, some students know I have some veterans that have to be, they're getting deployed. I can make arrangements. I got people who have to attend a seminar or something like that for work. Not a problem. We'll make arrangements. Okay. I'm here to work with you. We'll make it happen. But just don't ignore it completely and then tell me I forget, because I have information here to help you remember when things are due. Okay. Now you will have 11 lab experiments, and the experiments are worth 20%, and there are 2 lab exams. So I think labs 1 through 5 had, after that, you got one online lab, very short exam. Okay. And then the same with the final, which is the second half of the exams. So this, your grading percentage, a little bit different than the rest of Maricopa. It's instead of the standard 80, 90, it goes 100 to 88, 87.9 to 78, so on and so forth is given to you there. The summary of the percentage, homework is 15%, OS3 are dropped, activities 10% of your grade, lecture exams are 30%, there's 5, 1 comprehensive. Comprehensive is all chapters, all 16. Actually, it's gonna be 15 because I normally don't have time to put exam number, chapter 16. So it'll be 1 through 15 for the final exam. Then you have the nomenclature exam, which is worth 10%. And then the experiments, including the lab experiments, the lab exams, all worth 20%. Okay. Response time, like I said, if I can, I can access I do access my email on my phone. There's a question needs to be answered, and I just need my phone. I will answer immediately. Otherwise, if I need the computer, I will answer you and tell you I've got to get to the computer. Okay. All right. So attendance and policies and withdrawals. As per Maricopa, for online courses, if a student is not in attendance for 14 days, then I'm required to drop them. Now, what does attendance mean? Well, it's a variety of things. Actually, 2 things. Attending Zoom, obviously, is one, and doing assignments on Canvas. Logging into Canvas is not doing assignment, okay? So, but logging in and doing something, an activity or one of the homeworks, constitutes as attendance, okay? So it's a combination. So if I don't see you in Zoom for 14 days and I look at Canvas and you logged in 14 days ago, then I will send you an email to remind you, you gotta, do something here. Otherwise, I need to send in a withdrawal. Okay. Any question about that? Well, no surprises, right? All right. Withdrawal policy, I think I put in there the last day you can generate a withdrawal on your own. You don't need my signature, but other than that, if you need to withdraw, I can submit a withdrawal. So if you take the final exam, I cannot submit a withdrawal. Okay. Hopefully we don't need to talk about withdrawals because I expect all of you to do well and finish this class. Okay. All right. But if we have to, keep in mind that if you take the final exam, I cannot submit a withdrawal. All right. Any questions about that? Anything so far? All right. The other stuff here is for your reading. You find a lot of it also in Canvas. Technology, we're using Chrome as far as the browser on there. We're also using the lockdown modulus, and that's only for exams. Okay, it's just only for exams. It's not for the homework. We realize for the homework, you may need to get out of the homework to go take a look. The purpose of the exams is to keep honest people honest. Okay. And what was happening previously, not only here, but other campuses, what happens every time you go into Canvas to do an assignment, it keeps a log. And it logs whenever you stop looking at a page, which infers that you have moved another tab or you have moved or doing something and you're looking something up. I've had instances where I had like 90, 80 instances of flags. So there's a lot of looking up. Okay, but so to minimize that, we use the lockdown modulus. And yes, we understand that sometimes there's a glitch with the computer. Sometimes there's a glitch with your connection, and the lockdown modulus will flag it. But it tells you the time too. If it's a quick, 1 minute kind of flag, it's probably because there's a little glitch that happened, and we're not worried about that. It's these 10, 15, 20-minute lags that tell us that, there's something else going on. There's no reason to go out and look for stuff. And, we give you all the information here. You're only cheating yourself. Okay. All right. Any questions about that? Equipment, obviously you're here. Let's keep it civil. Yeah. I had one more thing I want to look at. Yeah, if you are caught with respect to coming out of your exam, then I will make note of it and alert you, and if necessary, send a letter out to the dean of students as to what's going on. Okay. All right, so our schedule, where's it at? If there's changes, and like I said earlier, that I will give you sufficient time after we're done with a particular chapter and activities, if the activities pertain to that chapter, as far as due dates. So those due dates will change as we progress. The homework will not the homework, the exams are pretty much etched in stone. So it's going to be on me to make sure we finish everything before exam time for that particular set of exams. And normally, like I stated, try to give you 1 to 2 days after we complete a particular chapter to complete. Now, I've in the past, and this is not the only class, but other classes have heard, I don't remember. I didn't know where this is due, and so on and so forth. Okay, first of all, Canvas, you can set up your notifications to alert you whenever there's changes that I do. Okay. So it can send you text, it can send you email to alert you that something's changed or there's something's due. You can also take the calendar feed. So if you go to Canvas to the calendar, and let me see if I can do that very quickly. Yeah, let's do that. So I can show you. All right, let's go back to the class. I'm going to share Canvas. All right, so if I go to the far left panel, is click calendar. I click that. And mine may look a little bit different, obviously, than yours, but in here, these are due dates for a variety of classes. For me, I'm going to make sure, let me take yours off, put yours on, I should say, and I will have it here. Okay, so this is the calendar from Canvas, and now at a glance, I can see what is due and so forth. All right. Now on the bottom right, there is what's called a calendar feed link. If I click that, this window pops up. If I copy that link, what that does is creates what's called the ICS file and email it to yourself. Okay. email that link to yourself, and then open it up in whatever electronic equipment that you're using, your cell phone, your computer. And what that does is it will take the calendar of Canvas and put it into your electronic device calendar. So now you can look at it at your leisure. You'll be looking at the same calendar. Okay. Now I've been told that it doesn't update correctly. I'm having tech support to find out what's going on, but we'll get that straight as soon as possible. Okay, so that is what. Let me get back to the course here real quick. Okay, so this is what this paragraph is all about. Is about the calendar feed and how to get it into your electronic device so that you always know when things are due. There'll be no surprises, and say, oh, I didn't know this was due, so on and so forth. Okay. So this is our particular class schedule. And that's today. So today we're going to do the welcome. Obviously, we're going to jump into chapter 1. Hopefully, we can get into maybe some chapter 2. Or maybe not. But I got to get 3 chapters done before the 5th, because that's our first exam, chapters 1 to 3. During exam days, if we were on campus, obviously, we'd be taking the exam in class, and that was it. But we're online. So during exam day, so on the 5th, if there are no questions about chapters 1 to 3, I will continue with whatever chapter we started, which would be 4. Okay. But I have no problem with spending whatever time necessary to go over material that maybe needs some further explanation. But if there isn't, we'll just continue with this chapter. What that does is, as we progress with the chapters during exam days, when we get down to the bottom here, like April 30th and May 7th, we're essentially done with the chapters, and that opens up Fridays as a study day for you to come into class with respect to come in with. Oh, excuse me. May I answer this question? Yeah, we will have reviews, and that's what I'm trying to say here is during the exam days, if there are no questions, okay, I will go over some material. Say for example, let me take a specific for you. Okay, that way there's no question. The 5th of February, on that day, we have exam number 1, chapters 1 to 3. Okay, so if 1 o'clock comes and rolls around, I will spend maybe a quick review on chapters 1, 2, and 3 to give you an idea of what to expect, what's coming up. Okay. During that time, if you still need further explanation, I have no problem to talk about whatever you want to talk about in chapters 1, 2, and 3. If there isn't, then I will continue with chapter 4. Okay. Does that make sense to everybody? Kahoot, it's a little bit difficult to do Kahoot. We had a little bit of challenge. I did try that, but exams are about 75 minutes long. Yeah, 75 minutes on the average. Okay. And like I stated, they'll be open from early morning to late at night. So there should be plenty of time there to complete that exam. All right. Now, with respect to the lab, that's the far right column. There's nothing due this week, but next week there is a lab 1 safety exercise. And you notice that on the 5th of March, there'll be your first lab exam, which will be over labs 1 through 5. Okay. Remember, the labs are on your time as far as going in there. You can go into the lab and start it and then not complete it and go back in there if necessary. Okay. And like I said earlier, plan to spend at least a couple, 2-3 hours on there because they could be extensive, like as if you were working in the lab in person. Okay. Hopefully, I'm not boring you too much, right? Okay, but look at here, March 15th through the 20th. Guess what that is? Spring break. Now, don't party too much, right? Because when you come back on the 26th, all right, sorry, we have an exam, chapters 7 through 9. So take your books with you when you go down to the Bahamas and study on the beach or wherever you go. All right, so we have an exam then, and then the final exam is scheduled for March 14th officially because this is a Friday class. And I don't know why SCC does this, but they always forget you guys. They take the Friday class. They don't schedule you. They don't pretend because they quote officially end the semester the Thursday. And I'm like, wait a minute, and that doesn't make sense because everybody signed up for a Friday class for your work schedule. Now you're telling them, no, you got to come in Thursday? No. Okay, so Friday which is the 14th, is the official last day for us. And that's the exam. Everything, if you're going to do anything with respect to homework, even though it's late, you got to get it knocked out. Otherwise, what happens? It becomes 0. All right. And throughout the semester, I periodically go through there and I start looking to see if, if you're missing something, I'm like, I give you a heads up. Hey, you missed this. All right. Any questions so far about the syllabus? You have the syllabus. Feel free to obviously read through it. And if you got any questions, feel free to send me a, yes, I have a question. Let's see. Yes, we're going to go through Canvas now. Everything you need will be on your course. So let me what I'm going to do now is share the Canvas course link. Okay. Their question is about extra credit, and the answer is yes. I have normally put in an extra credit assignment in there. I had to take it out. So I got to figure out a different way because the Flash program is no longer being used. And so because I had a simulation software and it wasn't being used, so I got to figure a way around that. And once I do that, I will submit an extra credit assignment and I'll put that in the final exam section. Okay. All right. Now, if you go into your Canvas course, mine's going to look a little bit different than yours, but it's set up to, is it better to take exam after lecture on that day since we'll be reviewing? That's a good question. It's really dependent on the students. Some students prefer to just get it knocked out early in the morning. And some students, I've looked at the times, I've just like evenly split, about half in the morning and the other half were toward the evening. And some, I always had a handful that came in with questions and then we worked on it. And then they went after the class and started doing the exam. So it's a tough question to answer, but it's really dependent on the student. Okay. If it was me, I would come in with questions, get a review, and then when we're done with lecture, then jump right in and knock out the exam while it's still fairly fresh in my head. Okay. All right. So now we are in the home page. So Zoom is set up to do the home page as this, and this is because SCC. I try to move it around, but I was told no, because they want everything to be consistent with all your other classes. So you have all these modules. Everything you need with respect to this class is set up in modules. So you got the welcome module, the first steps from SCC stuff. We got some. I added here in a module called Additional Chemistry Resources. These are simulations that will help you. We'll come back to that in a second. Okay. We also have all the slides. I added all the PowerPoint slides that I utilize during our Zoom lectures. I uploaded them in PDF format. So they're there for you, starting from chapter 1 to chapter 16. So you have access to that. I can't give you the actual PDF PowerPoints, but I can give you the PDF files. Yeah. All right. You also have an online lab tab for all the labs that you will be needing. Also already set up and ready to roll is the midterm lab covering exams 1 through 5. Okay. And even the final, which is about a week before the lecture final. So you have everything there with respect to labs. Now, every chapter has a module, and in there, in every module for that chapter, you have a PDF file labeled Overview, which is an overview basically of that chapter and what we're going to talk about. Okay. All the PDF files that are labeled chapter number 1, 2 through 16, then OER, which is the open resource, and this says text. That is your textbook. Okay. That's your textbook right there. Now, you have access to 2 types of videos. The first set, which is given here, is chapter 1 video. It would take you to a video that was created by Dr. Kim at SCC, who got a grant to make the chapter videos. And she created a chapter video of the topics in chapter 1 that we're going to cover. So she's doing a full lecture that you can see beforehand of that video. Okay. Now, not to be confused with the recorded videos that I have, that I will, once we're done recording, I get them, they're converted to MP4, and then they get uploaded to my YouTube channel. Okay. And you have a link for that. If you go up to the left to the panel up here, and you see the link where it says YouTube Zoom recordings, that would take you to the my channel for this semester with the recordings. Now, on that channel, you'll find recordings for the same topics from my GCC class. So you're welcome to view those. Okay. So what I'm saying here is this topic that we're going to talk about, you have a pre-video, if you will, from Dr. Kim, and then you have a post video of how we talked about it in our chapters. Okay. Not only for your class, but I also uploaded in the same channel my SCC class and for my 1 o'clock and my 4:15. And they're labeled what chapter and even to what slide we ended up with. Okay. Every chapter in their module has a worksheet. In that worksheet are work problems for that particular chapter. The answers are given at the end. So here's another resource for you to work the problems and then check the answers. If you don't understand the problems, this is a good place to bring them to class. I mean, bring the questions to class and we can actually talk about it. Okay. And then you have the activity for that particular chapter. And not all chapters here have activities. So this one does. Deals with chapter 1 and syllabus. Okay, 10 points. Now, once all that's done, the online homework, here's the link for that. Okay. All the homework, you have 2 attempts. Okay. The homework has 2 attempts and it will keep the lowest, that's not good. It will keep the best answer, the best score for your homework. Okay. All right. So there you have it. You have every chapter. So there's chapter 1, everything you need within the chapter. Okay. Now, in the final exam module, we have this, your exam, we have activity A, which I think most of you have completed it. That's just a quick check to make sure that lockdown app works and basically locks down the browser while you're doing an exam. And you only need it for the exams. You don't need it for the activities. You don't need it for the homework. Okay. You will have, I've not received the new link for my evaluation, but when it does come in, I will activate this instructor lecture and lab evaluation, but I don't have the new link, and it's a extra credit. Basically, you go in there, answer the questions for both the lecture and the lab, and then once you're done, go back to the assignment, hit submit, make a little note, tell me I submitted it, and then I get alerted and I give you your 5 points. I don't see the results until the following semester. And then I've included in there a practice final exam PDF and with the key. Okay, with and without the key. All right. Any questions about this? All right, so to the far left, you have, if you want to look at it a different way, what I like to look at is the syllabus link, because in that link, it has a course summary, which tells me which assignment is due when it's coming up. It's all listed there. Okay, so I can at a glance see what's coming up. Okay, I have the syllabus there for you to download and or view. The other way to look at this too is look at your assignments. If you click the assignments link, then what happens is you have it all broken down here with respect to all the assignments. You have the homework, you have the online labs, and then the exams, all broken up in assignments. Now, the question about the nomenclature exam, that is open. You can take it as many times as you want. You have to get at least 80%. And once it's 80%, I put in 80%. Anything below an 80% is not passable as per SCC departmental policy. So I have to put a 0 in there. I will not put a 0 in there now, but toward about a month or two into the semester, I will put a 0 in there to give you an idea of what effect that has on your grade. Okay, so that you can keep that in mind. Because Canvas, when you see your grade from your end, it just gives you the grade based on what you completed. And right now, if nothing's completed, you might be running an A, but you may have missed 2 or 3 assignments. And once I put a 0 in there, boom, you can really see what your true grade is, okay? True grade. What was the other question about the nomenclature? I believe, where's my chat? Someone had a question about the nomenclature. Yeah, oh yeah, you want to know if the nomenclature exam was found in Canvas. And yes, okay, it's right there. Okay. Well, I tell you what, we've done an hour. Let's see, we got one more question. Got it? All right, good. Let's take a quick 10-minute break, stretch your legs. All right. I want to, after we come back, I want to talk about some of these extra resources that I put on here for you. Okay. And then if there's no other questions, I'm going to jump into chapter 1. Okay. All right. So I got 2 o'clock when we say we meet here at 2:10. All right. So take a short break. We'll come back and then we'll kick it in full gear unless there's other questions concerning the syllabus and anything else. All right. All right, let me stop, pause. Okay, so yeah, it's there. Now, what people have done is subscribe to it so you can get um, oh, I'll answer that question here in a second. Some people subscribe to the channel, so whenever I upload something, it gets notified. You get notified that it's there. Now, the question is this. The assignment PDF for chapter 1, do we print that out? Or when we finish, then scan it, turn it in? No, let's go back. Let's go to it. Okay, chapter 1. Okay. Now, the only thing you need is it. Let me make sure I understand the question correctly. When you say the assignment PDF, are we talking about the activity? You can go ahead and unmute yourself. Is it? I can't see it. Yeah.
Any of them. Is there any assignments that we had to print out and then scan to turn in?
Yes. Well, not assignments. Let me restate that. The homework is all online. All the chapter homework is all online, so there's nothing to turn in there. Okay. The activities may require you to download a sheet and fill in some information, and or take a sheet of paper and you write the information and scan that and submit that. Okay.
All right. So just to clarify, you'll let us know when there's stuff like that to do.
Yeah, but the activity itself will show you that.
All right. Thank you.
Yeah. The activity, the instructions for that will be right in the activity. It'll tell you, write this down, take a picture of it, convert it to PDF, and submit that. Okay. All right. Any other questions? Now, the question I have for everyone is to make sure you know where your textbook is, you know where your overview is, you know where the videos are, the pre-videos and the post videos, and you know where the activities are for whatever chapter has an activity, and you know where your homework is, where the link is, right? Reason I state that, especially a textbook, is I've had in the past question maybe 2 weeks before the semester ends, where do I find the textbook? We're like, okay, all right. Yes, you can, if you want to download that book, that's just an additional resource that I put on in the textbook. But all that book, the other book that I put in as a resource is a standard textbook looking thing. The textbook here that we created, these were created by instructors here in the Maricopa Community Colleges. Okay. And some are very short, some are a little bit long, but that's a totally different textbook than the link for the textbook I gave you in the syllabus. Okay. Any other questions? Yeah. Well, I have one more thing for you that will help you with respect to additional resources. Now, I have in the additional chemistry resources, a couple of things. They're links, they're simulations. I would jump in there. I'm missing one. I got to upload it. I don't know why it's missing. But if I click on build an atom, okay, I get the simulation, and I'm trying to find out, because this is the simulation that uses the Flash program. And so far, it's working on mine. I don't know exactly when they're going to shut that off. They're supposed to, but we've got a variety of simulations. This deals with building an atom and trying to depict and show you that the proton, we're going to be talking about the atom later down the road. And we're going to talk about the three particles that make up an atom, which is a proton, neutron, and electron. And this little simulation kind of helps you build, give you an idea how atoms are put together. So if you grab a proton and just put it near the area, it goes to the center and you made hydrogen. And if I take another proton and guess what? I made helium, so on and so forth. I can add helium, I can add neutrons, they go to the center and not guess what? You know, I still have helium, right? And I can grab an electron, bring it nearby here, and it will go, oh, bring it a little bit closer, grab one, bring it a little closer, and it goes to the dotted line that represents the orbit of these electrons. But you can see here that I still have helium. And the only time I change that element is when I add a proton. Can you imagine that? That all the elements, we have 118 elements. And the only thing that distinguishes from hydrogen, which is number 1, to from number 118 is the number of protons. You know, and we can create 100, we have 118 different elements, and from proton number 1 to proton 118. And if it's like Legos, you're familiar with Legos. Imagine if you had just all blue little Legos. Imagine how many different things you can build with just those little blue Legos. It's the same thing here with the little particles of the particles of protons. And just by adding more protons, you create a whole new atom. Anyway, it's there for you. So you can kind of give you an idea of how to build an element. There are other ones. We're talking about balancing equations. It will make more sense once we get to that chapter. Dealing with polarity. This is very important with respect to the properties of chemicals and why things act the way they act. It has to do with something what we call polarity. And then there's a periodic table, which is an interactive periodic table that you can click on any of the elements, and you have to go through their website. And then it gives you information about the element. A little video pops up. Crazy looking scientist comes up there and talks about that element. So a lot of informative information for you. Okay. On the left, we have in the left column, we have a link called StudyMate. Okay. What I've done is I created what's called a nomenclature practice aid for you. If you click it, there's 143 chemicals, formulas, and names in this particular practice for you. So if you click that nomenclature practice, what happens is nothing. Wait, come on. Let's go. Why is it not working? Oh, still waiting. Oh, there we go. The length of the nomenclature exam is only 20 questions. You have about, I believe, 30 minutes in there for each trial. So, yeah, to answer your question. Come on, why is it not working here? Mm-hmm. Oh, there we go. I'll find out why the link, it could be from my end, but when you click it, you come up with this screen. Okay, now you have choices here. You can make flashcards or pick a letter or crossword puzzles, whatever you want. So if I click on flashcards, it takes that 143 compounds and it makes 143 flashcards. So this is the name of dinitrogen dioxide. If I flip the card, then keep in mind, it doesn't support subscript. So what you're reading is N subscript 2, O subscript 2. And that is the formula for dinitrogen dioxide. Okay. Lead, Roman numeral 2 sulfide. You can, that's the name. So in this case, that's the formula. Okay. And this will become more, this will help you quite a bit to work through the nomenclature exam. We do have a chapter on nomenclature, naming compounds, and so forth. Okay. Because eventually we're going to get to the point where you're going to have a sentence of a chemical reaction, and you're going to take the words in that sentence or two and convert those words into a chemical reaction formulas. Okay, so this will help you there. You could also play the where is it? Fill in the blank with those same 143. You know, type the answer there for aluminum hydroxide. And they're giving you the name, give you the formula. Or they do have crosswords. Crosswords don't work too well because it doesn't recognize parentheses, but you can try it, see if it works for you. Taking the same 143 compounds and put them in different formats. So you got a matching game that you can, here's the name, you know, lead 4 sulfate is the name. They want you to figure out, okay, which one is it? So, hey, maybe it's that one. So there you go, you're right. Okay, go to the next question. If you're not right, that's what happens. Okay, so it's another tool for you to help you with respect to the name. That's called StudyMate. In the link, I should have given you, if not, I'll find out if I did or not, the link to the course website. Bear in mind, like I stated, the Glendale Community College is hosting the course website. But in this website, there's a bunch of information for you that you can utilize. One, you have this already, but it's there for you. You have the textbook. You have the videos I talked about in the worksheets. You got a link there. We'll get there here in a second. But you also have a link in the course website to download the periodic table, which is very important because we're going to utilize that. Now, in 10130 here, if you ever need to use the periodic table to get information, use the one we supply, because things like, for example, the atomic weights can be a little bit different if you select a different periodic table. And then Canvas is not smart enough to know if I use someone else's atomic weights to do a calculation, your rounded answer may be a little bit different than what Canvas recognizes, and you'll be counted wrong. But which reminds me, if any answer in Canvas that you know is correct, but Canvas treats it wrong, let me know immediately. I will give you credit for it, because Canvas is not AI, artificial intelligence. It doesn't recognize a space unless you tell it to. So what we've been doing over time is teaching it to know, okay, this is space, ignore it. Okay, instead of, 12.02, 12.03 will be acceptable, accept that, things like that. Okay. All right. So the question is, well, depends. The question is how would atomic weights be different? They will be different in the number of digits that they give you. Okay, and sometimes some periodic tables have like 40 digits, and that's not going to work very well for you. Or they may have more digits with respect to the atomic weights. Okay, well, we'll have more to say about that when we get to that point. Now, on the Canvas course website, we have homework. Look at the far right. You see HW1 key, HW2 key, so on and so forth. That is homework that we used to give out when we were person to person in class. Okay, but no, we don't do that now. Obviously, everything's online. But the type of questions that were asked are the same, similar. Obviously, we're not going to ask you the exact same question. We're going to ask you the similar type of question, change the numbers. It will give you an idea of what kind of questions to expect. Okay. Now, each homework there is only 3 homeworks. It encompasses all chapters 1 through 16, but they're broken up in sections. Also here, if you look in the center, you see old exams. Again, we're not using the exact same exam now. However, the questions are the same, similar. Okay, I shouldn't say the same, they're similar. All right. Now, tutoring, this applies to SCC students, but you have tutoring at SCC, and I gave you the link for that and some information to that. Now, if I click over here, in the far left, you have this information already because I gave it to you. I'm in trouble here. I gave it to you in your Canvas course site. You have the chapter textbook, you have the worksheet, and you have the videos from Dr. Kemp, the links for that. These are the pre-videos on that particular chapter. If for some reason you need videos with captions, on the far right, they have captions there for you, okay? So a lot of resources. Some of the chapters she kind of broke up a little bit. All right, any questions about that? We'll go back to home. I think I covered everything on Canvas. If this is the first time you've been using Canvas, I do recommend to get in there and get familiar with it because you'll be using it quite a bit. Okay. Any comments, questions about anything in general? Feel free to unmute yourself and say what you want to say. Oh, 1 second, please. I got an emergency. Hold on. Okay, guys, I'm back. I may need to cut this short, maybe a little bit, not too much. Any questions on this? On this particular chapter? No? All right, then. That being the case, what I'm going to do is jump right into chapter 1. Okay. So, chapter 1. The way the chapters are broken up, we're going to be talking a little bit about chemistry now. And then the chapter 2, we're going to get into some calculations and so forth. We used to do it the other way around, but we thought we'll get you interested in the chemistry first, and then we'll bring the math here later on. And like I stated before, the math is not complicated. We're not doing sophisticated mathematics here, okay? So what exactly is chemistry? Now, I'm sure most of you have taken chemistry someplace along your educational career, high school, or maybe attempted this class before. All right. So Chemistry is simply this. It's the study of the composition, the structure, the properties, things like the physical and the chemical natures of matter. Okay. Because what we have determined is that matter, all matter is made up of atoms. Now, I was asked a question once. It says, well, how do we know these atoms are so tiny? How do we know that they exist? Well, I can tell you this. We have taken images of some pretty big atoms and there's some pretty big chemicals. Back in the 80s, IBM actually created, their scientists created a whole new device called scanning tunneling microscopy. And with that particular instrument, we were able to take images of atoms. Now, obviously, the resolution is pretty low. It's like looking at the moon and you see some stuff on the moon, but if you put in a telescope, yeah, obviously you're going to get a little bit better clarity of the different topological aspects of the moon. And if you're on the moon, obviously you get a little closer. So right now it's like looking at the moon. We have some pictures and some images of these atoms. Okay. Now, what are we going to learn about? We're going to learn about things that you may be familiar with before, but we're going to have a little more information about it. But obviously, we're going to talk about atoms and what they're made of. The three major subatomic particles, which is the protons, the neutrons, and the electrons. Okay. Now, these guys, FYI, are made up of even smaller particles, but we're not even going to talk about that. So we're going to stick with the protons, the neutrons, and the electrons. And that is what makes up the atomic mass of an element. Now, the thing that really got me interested in this chemistry was these crazy looking electrons. These electrons are so tiny, but they have such a big impact on the chemical properties of everything around us. And these are the same electrons that, you wake up in the morning, you got a bad hair day, right? Boom. Or you're wearing a pair of pants or a dress and it kind of clings to your body, or you're walking on carpet and you drag your feet and you touch something, you get a zap. Those are electrons. And they just have a very large impact on things in general. We're going to talk about a specific example to give you an idea. All right, we're going to talk about chemical bonding and chemical reactions. Now, there are millions and billions of chemical compounds out there. If all those things out there, there's only 6 types, not the reactions, I'll get to that. There's only 6 types of reactions, different types. And as far as chemical bonding, there's only 2 types of chemical bonding. There's one type of chemical bonding that these electrons, again, are shared. They share to actually make a connection. And then there's another type of chemical bonding that they don't share anything and they just attract to each other like 2 magnets. And that's it. 2 types. Okay. The reactions, there's 6 types, of which some of these you're familiar with. If you drove a car today, you're familiar with one type of reaction called a combustion reaction. Okay. If you have you're having an acid problem because you got too much acid in your stomach and you took some Tums, guess what? You just did another type of reaction, a neutralization reaction, where you reacted an acid in the base. We're going to talk about the periodic table. Okay. The periodic table has a vast amount of information that we're going to utilize. Now, the one that where'd it go? This is the one we supply. Okay. Here's a periodic table. We're going to be at one point in time, you're going to be able to look at that periodic table, pick any element, and you're going to be able to determine if it's a solid, if it's a liquid, or a gas. Okay. You're going to be able to look at any of these elements and look at, say, number 11, sodium, and compare it with potassium, number 19, and be able to say, oh, okay, from a size perspective, Potassium, number 19, is much bigger than sodium. Okay. And you'll be able to look to see how many electrons, at a glance, you can take a look at carbon, number 6, and right away say, okay, carbon's number 6 has got 6 protons, 6 electrons, and 6 neutrons. Without having to memorize it, just by knowing where carbon's at, its number, okay? And you'll be able to determine things like which ones are a metal and which ones are non-metals. Of these elements, there's only 3 types. There's a metal, there's a non-metal, and then there's a metalloid. Okay, that's it. And we'll be able to learn stuff like that very quickly. So we will be accessing that periodic table quite a bit and talk about these trends I just mentioned. Okay, we're going to talk about acids, which right down in your stomach, you got an acid called hydrochloric acid. A base, probably in your kitchen, you got a base called sodium bicarb or baking soda. And guess what? When I take an acid and I take a base and I mix them up, I neutralize it. That's a chemical reaction. Electrolytes, okay? Electrolytes are nothing more than those elements on the periodic table that have either lost electrons or gained electrons. And you're familiar with electrolytes because without them, you wouldn't be sitting here bored listening to me. Okay? Because those electrolytes are the ones that conduct electricities in your body. And when you do a workout, what do they tell you to do? You got to hydrate. Well, yeah, you hydrate more water, but you also need electrolytes. So such things as Gatorade and Pedialyte, they have electrolytes like sodium, potassium, things like that, because your body needs those ions to conduct electricity. If they're not there, your muscles won't work, your heart won't work, your brain won't work. Okay, so electrolytes. So we're going to talk at length about those. We're going to talk about the mole. Well, what exactly is the mole? Nothing fancy. If I ask the question, what is a dozen? You already know what that is, right? It's 12. And even if I say what's a baker's dozen, you'll say 13, which is correct. The mole is nothing more than a number. Okay, it just happens to be a humongous number. It is 6.02 times 10 to the 23rd. In other words, take 6.02 and move that decimal point over to the right 23 times. And that's how big that number is. Which means that if I were to count that number at, say, 1 number per second, 1, 2, 3, that way, by the time I get to the end of that number, a few thousand years have passed if I was counting at 1 number per second. That's a big number. Stoichiometry, big fancy word for something that you're familiar with already. I got a unicycle frame and I need a tire. How many tires do I need? Well, obviously I need 1 tire, correct? I got a unicycle frame, 1 tire. The stoichiometry, the relationship between the two is a 1-to-1. If I have a tricycle frame, how many tires do I need? 3, right? I need 3 tires for the tricycle frame. So that relationship is 1-to-3. Not all chemical reactions are a simple 1-to-1. Some of them require 1-to-2, 1-to-3. Some may require 2-to-3, 4-to-5, and we're going to learn about that stoichiometry, that relationship, because we need that information when we start calculating things. We want to do some calculations. We're going to talk about intermolecular forces. These are the forces that molecules have with each other. We know that if I had a cup of water and a cup of honey and I flip them over, we know who's going to win the race, right? The water is, right? Because the water is less viscous, so it's going to flow quicker. So why is the water more viscous? And that is because these intermolecular forces of the molecules of water, those forces with molecules with each other, is much less than the intermolecular forces of the honey molecules. They're much stronger, which results in a more viscous material. Okay. We're going to talk about solutions and maybe touch on the gases a little bit. Okay. Now, different areas of chemistry, like any professional field, there's a variety of different amount. Engineers, you got chemical engineers, you have mechanical engineers, okay, so on and so forth, structural engineers, electrical engineers, doctors, you got pediatricians, or orthopedic, and line growth. Well, organic chemistry, same way. My specialty, my undergraduate degree was in organic chemistry. And that is the synthesis, the making together of chemical compounds. Some have medicinal value, some did not. I kind of liked it because it reminded me of my old construction days when we built things. To me, I was just nothing more than building chemical compounds. Okay. And you have biochemists, people who deal with the chemistry of life. Okay. Some people like Dr. Kim Smith, if you view those videos, her doctorate is in chemical education. Teaching chemistry, then environmental, which is a big field, and then analytical chemistry. Those guys are very meticulous about measuring things. Organic chemists, I tend to think we're more like the kitchen chemists, where we kind of put a little of this, a little of that, though we know how much you put in to make something. The analytical chemists are the ones that want to measure 0.000001 and be very exact. But that's okay. All right. Chemistry, I mentioned to you, no, it's not the most important class in your life, but it is the one course, one field that affects every aspect of your life. Even as you're sitting there, there are tons of chemical reactions that are occurring just to be able to sit in your chair. All kinds of things, to breathe and so forth. Everything around us has had some chemistry involved with respect to either make that product. Batteries, if you have an electronic device right now working on batteries, you got a chemical reaction occurring there in those batteries. And those batteries, a chemical reaction produces these electrons that allow you to do your Facebook or whatever it is, TikTok, whatever the new app is. All right, so we have electricity, very, very, lot of chemical processes. It could be either chemical process or it could be mechanical thing. Anyway, TNT, trinitrotoluene, otherwise known as dynamite, a very, very explosive material. So it just gives you an idea. Now, as scientists, we utilize what's called the scientific method. And, you probably do it without even thinking about it, okay, if you're observing something. Yeah. For example, you make an observation, something occurred, and you observe it. Okay. Well, after you observe it, then you make maybe a hypothesis about that observation. Why did whatever you observed occur? And then after that, you might want to research your hypothesis to find out if other people have done anything in that area. And then you might want to design experiments to look at your experiment, okay? So an example would be like, all right, so you took a soda, you stuck it in the freezer, and that thing exploded, made a big old mess in there, right? So that's your observation. You notice that your soda exploded in the freezer. So you make a hypothesis, you make an educated guess as to why you think that happened. Well, you say, well, soda is made up mostly of water. Maybe the water expanded when it froze. Okay. So you research it, look around other science sources, and you find out if anyone's done any type of work, get you some background behind it. And so then you start, okay, well, let me perform some experiments. So you might want to try different amounts of soda, different types of soda, check the freezer temperature, change maybe different levels of freezing as far as temperature is concerned, try different containers, set up a series of experiments to see if the same thing occurs, okay? And then You analyze what you have found with respect to your experiments, and if necessary, maybe create new experiments and repeat them. Okay. Now, based on all that information, you draw a conclusion, and you conclude that yes, when I put water in the freezer in a closed container, it will expand. Okay. And that is your conclusion. You report it, maybe you publish it, and you allow other scientists that will repeat that. Okay. So we use a scientific process made up of 6 steps, basically. Observations are very crucial. Okay. That periodic table, we're going to have a chapter in the periodic table. The original periodic table was made back in the 1800s. And the way it was put together is they didn't have all this fancy equipment we have now. They based their conclusions strictly on observations. Okay, so the labs you'll be doing, again, they're going to be, you're going to have to observe and, very specific observations. So you be careful when you make an observation. For example, something like something is color. Not color is not necessarily, it's colorless. It's not necessarily clear. Okay, you can have a color solution that's not clear, as far as clarity. So you got clear, cloudy. Or you can talk about the state of the matter. What state is it in? Is it a state of a solid, a liquid, or a gas? Okay, things of that sort. Okay. The question is there a 4th state? Yes, it is. Okay, which we're not going to talk about. We got solid, liquid, and gas, and then the 4th state is plasma, which are charged particles. If you ever saw the aurora borealis, those are charged particles. That is the 4th stage of matter. But we're going to stick with just simply solid, liquid, and gas. Okay, as we stated, matter is made up of atoms, and that matter is defined as anything that has mass. Okay. Now you're going to see a lot of diagrams that kind of depict numerous things. First thing to notice here, we got 3 diagrams, and we got some circular objects. Okay, those represent some type of an atom of something. Okay. First thing to observe under the one labeled solid, that these circular objects are put together in a very structured, ordered position. So that would indicate that is a solid. That would represent a solid, very structured order. A liquid, okay, we still have the circular object atoms, but they're not as structured and ordered as in the solid state. Okay, they're moving around a little bit here. Okay, so that would represent a liquid. And then finally, in the far right, you can see that the circular objects are all separated from each other. There's not a lot of interaction, okay, between them. In fact, this would be a good example of water going from ice to liquid to gas. Okay, good example. So you're going to see a lot of diagrams like this. What do we know about the properties of solids? Okay. Well, first of all, solids have a fixed shape and they have a fixed volume. So a rectangular box or a cube has a fixed shape. It has a fixed volume. We can easily measure the volume by just measuring length, width, and height, right? That's a volume. But let's say it's a human body. How can we measure the volume of a human body? Any ideas? A cube, a rectangular box, no problem, right? We can get a measuring tape and measure the 3 length, width, and height. We got that. But what about a human object? Or what about a pen? How can we measure the volume of the pen? Anybody have any ideas? What could you do? I'll give you a hint. Jacuzzi. You're like, what? Any ideas on how we could measure the volume of some solid that doesn't have an irregular, has a regular shape? What we got here? We got one answer coming up. We can exactly displace. And I say jacuzzi because we know that we can get the volume. We can measure the volume of a jacuzzi or a bathtub or a big container. We can know the volume of that liquid. And then you jump inside and fully immerse yourself. Well, that volume is going to go up, right? And you have somebody measuring that volume, the new volume height. You can calculate how much volume your body displaced. Okay. Now, why would you want to know that? Because down the road, we're going to talk about a property called density, and we need to know the volume. All right. So solid atoms, they vibrate. They still continue to vibrate when they're in solid state. In fact, matter atoms will continue to vibrate and move until they hit what's called absolute zero. Now, we've come close to hitting the absolute zero. It's negative 273 degrees Celsius. We've come close, but we haven't hit it yet. And at that point, supposedly, matter stops moving. Because it is vibrating, they are vibrating. Solids can be crystalline in nature, or they could be non-crystalline in nature. Okay, meaning they either have a very structured, ordered system or not. Because they're so close together, they're not very compressible. I can't bring them any closer together because what's happening, if I bring them closer together, around those circular objects are electrons. Okay, always remember that. There's electrons around them. Electrons have a negative charge. And what do you think is going to happen if I got two negative charges coming in together? Okay, what do you think might happen? If I got a negative charge coming in to another negative charge, you think it would be an attraction or a repulsion? You ever cross the wires of your car when you try to jump start it? That, right? There's a repulsion, okay? Because a negative repels a negative. And so think about this for a moment now. Those round spheres, they got negative electrons around it, and we got more next to it, also negative. They're going to repel each other. They get close to each other, but they're going to repel each other. The point is that you will never, ever really, truly touch another object. Because what you're doing is when you grab something, you're grabbing the outside, the electrons on the outside, and they're repelling from you. So you got to put some force to hold on to them. Okay. So, and you can't, they're not compressible. You can't get any more space in between them. They're not very compressible. Now, here's the density part. We introduce you to this new equation. You may be familiar with it, but it is simply nothing more than a ratio. We're going to use a lot of ratios down the road. You're already familiar with ratios. Dollar per hour, miles per hour, okay? Miles per hour per second, acceleration. These are ratios. The density is nothing more than the ratio of mass divided by the volume, okay? Mass divided by the volume. And we can write that ratio with respect to, no. The question is, any other exceptions? To my knowledge, water is the only material that expands on freezing. And that's what I was going to say here, that ice, when liquid goes to ice, when it forms the crystalline structure, it actually expands. Okay. And so what happens is water, what we do is put this in long-term memory. The density of water at 25 degrees is 1 gram per milliliter, 1 gram per milliliter. We use that as our benchmark to determine whether something will float or sink. If a material has a density greater than 1 and we put it in water, it will drop like a rock. If something has a density that's less than 1, it will float, okay? So if we take water and we actually take 1 gram of water and measure its volume, we find that 1 gram of water has a volume of 1. So it's 1 gram divided by 1 milliliter, which is 1 gram per milliliter. Okay. Now, if we take that same 1 gram of water and we freeze it, guess what happens to the volume? Instead of being 1 milliliter, now it could be 1.1 because it expands. And now if you divide 1 divided by 1.1, guess what number you get? You get a number greater than 1 or less than 1? 1 divided by 1.1, you get a number less than 1 or greater than 1? What do you think? One divided by 1.1. What do you get? You get about 0.9. So you get a number less than 1. Got 2 answers here. Let's see. Yep, about 0.9, you get smaller, which means now that ice, water that now is in the ice form, has a density of about 0.9, which is less than 1, which means it floats. Okay, so nothing magical happened to water when it became ice. Okay, the only thing that happened, that ratio changed. The volume, the denominator got bigger. And so the ratio of density is smaller. Therefore, it floats. Okay, about 0.91. Yeah. And that's very a thing for ice. Ice has that function. Most other liquids, when they become solid, if you put them in the solid state and you put them in the liquid that they're from or whatever they are, they tend to sink. Okay, solid, with the exception of water because they expand. The other aspect about solids is they do not mix very well. You know, I can put 2 solids together and nothing is going to happen. No chemical reaction is going to occur because they can't really get together. They're in the solid, they're locked. Okay. No diffusion can happen. Now, with respect to liquids, liquids can take the shape of the container and they have a constant volume. Okay. Case in point, gallon of milk, right? I got a gallon of milk. I got its container. It has a shape. That liquid has that shape of whatever that gallon shape is, but I got 1 gallon. And if I take that 1 gallon of milk and I dump it into a 55-gallon drum, I still have 1 gallon of milk, but now its shape is different because it's in a different container, right? Different liquids flow at different rates. Earlier, I mentioned about water and honey. The difference is because their difference in viscosity has to do with this intermolecular forces. These are forces of atoms or molecules have with each other. Okay, if it's stronger, it has a great effect on things like boiling point and viscosity. We will eventually get to the point that we can look at 2 different compounds and compare and say which one will have the greater boiling point, which one would be more viscous, because we're going to determine by analyzing the compound the intermolecular forces, which then we're able to make that decision as far as boiling point. Liquids, not very compressible because like solids, they're together pretty much. There's not a lot of free space in between them, which is a good thing because that's why we can have hydraulics, okay? Yeah, without hydraulics, these are liquids, oil in there, you wouldn't have such things as power brakes and power steering, okay? If you ever try to drive a car with no power steering, it could be very challenging when you first start. Liquids tend to have a higher density than gases. Okay? And if the liquids are soluble, they will mix uniformly. So if I have a, let's say, a cup of water and a cup of, say, alcohol, like isopropyl alcohol, they will dissolve. Okay, I got 2 cups total volume now. and they will mix uniformly. Unlike a cup of water and a cup of oil, they're not going to mix, okay, uniformly, because they have different properties, and one's oil, one's not. With respect to gases, they have no shape. They take the shape of the container, much like liquids, okay? Because the atoms are so far apart from each other, they will expand and compress, okay? So if we decrease the volume of the container, the pressure goes up, really, and the atoms get closer together, okay? Now, here's something important at this point in time. Gases right now at Chem 130 do not have a set volume. You will learn down the road that only under certain conditions that gases will have a set volume. But right now, they don't have a set volume, okay? And they tend to have low densities, much, much less than one. Okay? They will mix fairly completely with other gases. Our whole atmosphere is made up of a mixture of things like nitrogen, oxygen, carbon dioxide. Notice we introduce you like N subscript 2. That denotes that there are two nitrogen atoms bonded together. Notice oxygen, O2, when we say, and these are subscript 2s. That denotes that there are two oxygen atoms together. And if we go across to carbon dioxide, carbon being the first atom presented, written, that is the central atom. That's how we write things. And then what follows that is all the atoms that are bonded to the central atom. So in carbon dioxide, carbon is a central atom, and two oxygens are bonded around the carbon. We will learn how that bonding goes on, specifically how it happens. Yeah, talked about compression. What was the question about compression?
Is the set volume come from compression of gases?
Oh, no. What happens that only under certain temperature, which is 0 degrees, what we call standard temperature and pressure and 1 atmosphere pressure, all gases have a volume of 22.4 liters, but only in those conditions. Okay. So anything out of that, the volume they have is dependent on the container that they're in. Just like they take the shape of the container, and they also take the volume of the container. Unlike the liquids, they take the shape of the container, but they still have a known volume. I got a table here that will summarize all this. Okay. Gases, they exert pressure because they're hitting the sides of containers. You go out, get in your car, you see your tires low, maybe it's hitting 25 psi, pounds per square inch. So what do? You go to Quick Trip, Circle K, hop in some air, bring it up to 32 psi. What have you done? You have introduced more matter into your tire. Putting more matter into your tire, more matter is pouncing up the walls, and your pressure goes up. Okay. This table summarizes everything we just talked about. Solids, they have a fixed shape and they have a fixed volume. Okay. We either can measure that volume of that solid directly, or we can measure it through displacement. Okay. No, liquefied gas is liquefied gas is a liquid, because that gas, whatever it may be, like oxygen, has been converted to its new state, which is a liquid. It's still oxygen, but it's in the state of a liquid. Okay. Under pressure. The moment we open the container, because here on Earth, under those conditions, when you open the container of nitrogen, then it goes back into the liquid phase. Does that answer it, Thomas? Another example we're going to talk about is carbon dioxide, dry ice. Dry ice is nothing more than solid carbon dioxide. Okay, so all we've done is change its state, went from a gas to a solid. So any gas that we can change its state, it's still that gas, it's just in a different state. Hopefully that answers your question. Okay. Solid liquids. Liquids don't have a fixed shape. Okay. Depends on the container. And they don't have they do have a fixed volume. Okay. Gases at this point in time do not have a fixed shape. They take the shape of the container and they don't have a fixed volume. Down the road, when we're under what is called STP, standard temperature and pressure, they will have a fixed volume, but not right now. Okay. When we talk about physical and chemical properties, that's what we're going to talk about. What do we mean by physical properties? Those are things like the color of the material. It could be colorless, it could be white, it could be black, purple, whatever it may be. It may have an odor. Okay. I wouldn't recommend tasting it, but it may have a taste. It might have a texture. Okay. Or it have a specific melting point temperature, like butter versus oil. We know that butter is a solid here at room temperature. As we increase the temperature, it becomes a liquid. Okay. That is the melting point. Its physical state, whether solid, liquid, or gas. Those things are physical properties. And also density. Everything has a density. Okay. What else? Solubility. Is it soluble in water or is it soluble more in oil-like? Or does it conduct electricity? Metals conduct electricity. That's a physical property of the metals. And some metals are soft, some metals are very hard. Sodium metal, for example, is a very soft metal. Iron's a little bit tougher. All right. So those are the kind of things that are physical properties as compared to chemical properties. Wholly different story. Okay. These are properties and how a substance reacts or behaves under certain conditions. Is it explosive? Could be. TNT, dynamite, it's a chemical compound, trinitrotoluene, but it's very unstable and it could explode. Corrosive, hydrochloric acid, very corrosive material. Or, is it toxic? If you were to ingest it, would it kill you? Yeah. Okay. Those are the things that are chemical properties. What about inert? What does inert mean? Does anybody have an idea what inert? INERT. What we got here? No energy? Not quite. Not quite. But it's a good thought there. That works. Okay. Inert would be something that, with respect to chemistry, chemical properties, not reactive. Okay. Gold, for example, is considered a noble metal because it's fairly inert. It's unreactive. In other words, gold could be buried, thousands of years ago, and you dig it up here today, and it's still as shiny as the day it was buried. And that is because the gold itself is very unreactive and remains essentially the same. Okay. So in your periodic table, on the far right column, there's a whole column of elements that are inert. They're called inert gases or noble gases. They are very unreactive. They don't react very readily. Okay? And there's specific reasons why they don't. And when we get to that, you'll understand why they are considered inert. Okay, things that are reactive, things that rust, oxidation, decomposes. Some chemicals, when you heat them up, they decompose. Okay, so those are chemical properties. And when we talk about chemical properties, what's happening is we are literally changing the structure of that material. With respect to physical properties, when we go from solid, liquid to gas in water, when ice, water in the form of ice is still water, H2O. And when we heat it up to a liquid, it is still H2O. And when we continue to heat it, guess what? It is still H2O. We haven't done nothing to change the structure. Okay. Just all we do is change the physical state. It's like the question about the gases. We can take oxygen, which is a gas here on Earth, and we can put it under pressure, lower the temperature, and we force the atoms, molecules of oxygen to interact with each other under pressure, and they become liquid. They change their state, their physical state. Okay. But we haven't changed the structure. Chemical properties, we literally change the structure. For example, does anybody know why, if you're baking chocolate chip cookies, why you put baking soda in them? Why does the recipe call for baking soda or sodium bicarb? I was going to say the answer is inert. Okay, expansion, that's correct. But what is expanding? Anybody have an idea? Not quite to put the structure together. Okay. The release of gas, exactly. And what's happening is sodium bicarb, baking soda, when you heat it, decomposes, it breaks down. And when it breaks down, one of the products it makes is carbon dioxide, which then goes through the cookies to cause the chocolate chip cookies to rise. Okay. Otherwise, you're going to have flat chocolate chip cookies. And the same is true if you put bugs in your bread when you're making bread. Bugs? What do you mean bugs? What kind of bugs do you put in your bread? Anybody know? Yeah, yeast, exactly. I call them bugs because they're plants, but they're microorganisms. Okay. And guess what? What do they do when they? Why do you put bugs in your bread? Again, you want the gas to be emitted because you want your bread to rise. And what's happening? The yeast takes the sugars and so forth from the bread, breaks it down, metabolizes them. And like us, one of the byproducts of our metabolism is carbon dioxide. So the bugs eventually emit carbon dioxide, which causes the bread to rise. And then when you bake it, you kill the bugs. So you're eating the remnants of the bugs. I may ruin some of your dishes here because I'm going to tell you what you guys are eating. Break it down to the chemicals. And so the bread rises, okay? And if you don't give time for that metabolism to occur, you're going to have unrising bread or matzah, okay? So chemical reactions occurring. All right, now the physical changes, these you're familiar with. I'm sure you are. Maybe a couple you may not. So if you go from solid to liquid, we call that melting. Okay, so a stick of butter, we stick it in a pan, we heat it up, it goes from solid to liquid. That's melting. Okay. We go from liquid to gas. This happens every time you put a pot of water to make some spaghetti. What do we call that? Boiling, right? And we call it vaporizing, or we call it evaporating. All right, so we get that part where you got a pot of water, you're boiling, and it evaporates. Well, what happens? Why does, if you take a cup of water and you put it in your kitchen countertop and you come back a couple weeks later, what's happened to the liquid? Okay, is the liquid still the same volume? Okay, you got a cup of water, kitchen counter, Come back a couple weeks later, what's happened to that liquid in that cup? Any ideas? Is it still there? No, of course not, right? It's evaporated, right? It's gone. But why? Now we understand that when we put that pot and we heat it up and we put energy into the system, we boil that water away. We understand that part. But why is it that a cup of water that we didn't do anything and it's in your house in the room temperature, 25 degrees Celsius, why did it evaporate? Vapor pressure? Almost, not quite though. But yes, vapor pressure, we're going to learn about that. But vapor pressure, we deal with that when it's a closed container. That pressure eventually heats up. So if I got a soda pop and I shake it up, I build up pressure in the empty space, and that's called vapor pressure. But here, no, the oxygen has nothing to do with it. Just a cup of water, sitting tabletop, and it evaporates in 2 weeks. Right? Everybody agree on that, right? No, it's a physical change. Evaporation is a physical change, so there's no chemical compounds that are separated. Nothing's broken down. When you take water and I freeze it, I still have the formula H2O. And when I make it into a liquid, it is still H2O. And when I make it into a gas, like the clouds we see out there today, that's H2O. It's still H2O. So nothing has been done to change. It's a physical change. Remember that. A physical change, we don't change the structure of the compound. Chemical change we do, like the sodium bicarb. We broke bicarb completely, made the gas. No, here's the thing. That water, this is a demonstration that molecules move. Even though you're sitting there and you're like, well, I don't see anything moving. Well, they're moving. Okay. And what's happening, sunlight, no, it's in your house. In fact, we could cover it with something and it will evaporate eventually, but not as much, but it will evaporate. But that's good. I like to see the brain, the gears are kicking. Okay. Gears are kicking. Earlier, I said that all molecules are moving all the time. And even in the solid form, they're vibrating. Okay. Now, liquids are moving relative to each other. Now, there are some molecules of that water liquid on the surface. Okay. Now, if you can imagine, you know how they shoot, have you ever seen them do the Powerball? They're taking the numbers out and that thing's floating in there and the little balls are bouncing around. Okay. Well, those are the water molecules that are bouncing around with each other. And some of them have energy. Now, the ones that are on the surface, just like a cue ball gets hit. And guess what? The ones in the surface absorb that energy and they get kicked out and go into the vapor phase. And that process continues with time over and over and over again. Eventually, what happens? All that water has evaporated. And all that happened, you didn't put energy into the system. You just had the molecules themselves moving and bouncing off each other and transferring energy back and forth. And the ones in the surface picked up enough energy to be kicked out of the liquid phase and shoved into the gas phase. And hence you have evaporating. So nothing magical, no chemical interaction occurring. It's just a transfer of energy from one molecule to the other. Okay. No Harry Potter stuff occurring there. Okay. All right. Gas to a liquid. Condensation. All right. Let me ask you another question. I got a cup of soda pop here. All right. So let's assume it's empty. Throw some ice in there. Throw my soda pop in there. Let it sit on the bench top. And then I come after a couple minutes on the outside. It gets liquid on the outside, right? We call that condensation. Where did that water come from, though? Where did that condensation come from? Why did it get wet on the outside of my container? There's water vapor in the air, and that is correct. Now, obviously, we live out here in the desert. The humidity is not as great. Let's say you live, and the temperature is involved here, and I'll explain that. Good point. So we live on the desert. There are water molecules out in the air. It's called vapor. Okay. And when those molecules are relatively high energy, okay, because they're floating around here, they have a high energy compared to a liquid, compared to a solid. And so as those molecules come and contact the surface of my container, the energy those molecules have get transferred to the container. Remember this, Mother Nature, when it comes to energy, always goes from a high energy state to a low energy state. Okay. Mother Nature it's downhill from high to low. Now, if it's analogous to rolling down a mountain. Rolling down the mountain is pretty easy. Just start rolling, boom, boom, boom. Okay. Now, to get back up the mountain, you got to put energy to get back up the mountain. All right. And yes, we can go back up the mountain, but you got to put energy into the system. Energy spontaneously goes down the mountain. And so that water molecule that's out here has high energy, hits the container where it has lower energy, and it transfers that energy to the container. So that molecule that was in the air as vapor, its energy state gets lower, hence it condenses. It starts to interact with the other molecules of water much more readily. And it condenses and it forms an outside of your container. It's a function of energy. Remember this in this class. Mother Nature always goes from high energy to a stable state. Classic example that I use a lot is taking a shower, a hot shower. Okay, first thing in the morning, it's a little chilly out here. So you take a nice hot shower, it's steaming, you're doing good, boom, 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 you're done. You open up the shower curtain, you jump out, what happens? It's a little cold, right? A little cold. Why does it get cold? Okay, because again, you're in the shower, your energy is much greater because you just got hit with a lot of hot water, and you step outside and your energy state is higher than the atmosphere. So your energy moves away from you to the atmosphere, drops your temperature, you get cold. So what do? You jump back in the shower, right, to warm up. Now what's happening? You warm up. Why do you warm up? Because now your energy level is much lower than the shower and energy level. So the energy from the shower goes back to you and you warm up. There's a transfer of energy back and forth. Eventually it stops because everything equilibrates. Even a cup of coffee, we got chest up. Even a cup of coffee will go to room temperature or whatever temperature you're at. Okay. All right. So it's condensation. Now, this might be a new one for you. This is going from a liquid to a solid. Okay. It's freezing. Wrong one. The next one, you know what freezing is. This one, when you go from a solid to a gas, we call that sublimation. And the classic example of this is dry ice. Okay. Dry ice, when you go to Fry's and buy yourself some dry ice, maybe they might give you some free. It's a solid chunk of ice. It's not ice, it's solid carbon dioxide. And that goes directly from solid carbon dioxide to gas. Okay. You can put it around your plants. Why would you put dry ice around your plants? No. Dry ice is carbon dioxide. Does it give you a hint? Same reason you talk to your plants. Why would you talk to your plants?
It's because plants use photosynthesis to make glucose so that they can eat.
They need carbon dioxide, just like we need oxygen. Plants need carbon dioxide. So you want to help your plants out? Talk to them. Okay. Talk to them because you have carbon dioxide coming out as you exhaust, or you can put a little dry ice around it. Don't put the dry ice on them because it's a little cold. You might kill your plant. Okay, put it around it. Anyway, solid to gas is called sublimation. The opposite, going from gas to solid, we call that deposition. So we can take carbon dioxide and we can put it in a little instrument and move it back to gas. Okay. All right. Jessup, I see you there. Good. I'm going to mark you off.
Thank you.
All right. Now, physical changes. I'm going to introduce to you, we're going to introduce to you a process in the chemistry world and how we denote that. And let me get my little marker here. Two things. We have this arrow here. Okay. So that arrow represents that something is happening to a chemical. Okay. Something could be a chemical process or it could be a physical process. Remember, a physical process, we don't change the structure. We do something to it, going from solid to liquid to gas, but it still remains whatever we started off with. A chemical process, we totally change the chemical formula. Okay. And we're going to learn more about formulas and how they're put together and so forth. So the arrow represents a chemical process. Now we have two types of arrows. We have a one-way arrow, and this is pointing from left to right. So that's telling you that's a one-way road. Okay, well, in one direction, at least for this example. But we can have a two arrow process, which we're going to talk a lot about down the road, where that tells you that process can go in both directions. Okay. All right. Now, let me change my color here for a second. We have H2O, which is the formula for water. Notice that we have a subscript 2 that tells you there's 2 hydrogens. Okay. Subscript 2. So it's not an uppercase, there's a superscript, it's always a subscript. We have water here on the left side of the arrow. Normally that is called the reactant. And we have, guess what? The same structure on the right side of the arrow. Nothing has changed. So that is hint number 1 to tell you that I have a physical change because structurally the formula did not change. And then on top of that, they're even telling you the physical state because they're saying water liquid, which is L in parentheses, going to water gas. Okay. And so you might find as we talk here, until we learn more about this, you're going to find chemical formulas that are going to be totally foreign to you. And that's okay. We'll learn about them later on. What I want you to take away is to analyze the formula. Does that formula look different? Okay. H2O is still H2O to the right of that equation. So analyzing that equation tells me that we did nothing to water chemically. And it's simply a physical change. And then on top of that, they're also giving me the state that they're in, liquid to gas. So we simply call that boiling. That's an example of boiling. Okay. All right. So we'll have some more examples in a second. All of this that we talked about is a diagram that kind of breaks it all down, melting, going to boiling, and to create the gas. Now the states are solid, liquid, and gas. Now here's the thing to remember. These are physical changes, okay? Has nothing to do with the structure. And so if you look at the sphere, still the same shape, no change in color, no change in size. It's still the same. in whatever phase. What we've done by putting energy into the system, we've broken up the interaction in between the compound, whatever it may be. There's an attraction. Those are those intermolecular forces. And when you put energy into the system, you break up that interaction and you cause the interaction to be removed so they goes from a solid to a liquid. And as I continue to put more energy into the system, I drive that interaction even further away. So now the interaction between the molecules is much more separated. Okay. And it's all about energy. So I'm putting energy into the system in that direction from left to right. And guess what? If I take energy away from it, I just simply reverse it, going from right to left. Okay. Remember, we talked about the condensation. Here we got the gas molecules that are floating in the atmosphere. And they touch my glass container, which is cold. It picks up some of the energy that the gas molecules had. So it makes them to interact closer together and condense into the liquid. And if I remove even more energy, eventually I get it back to an ice. Okay. So it's about the transfer energy back and forth when it comes to physical changes. We have done nothing to the actual structure of the compound. Okay, that's important. We don't want to mix up the two, the chemical and the physical change. Okay, so more on physical changes. Like we stated, the atoms are always moving, even in the solid state, they're vibrating. Okay, and we tap into that. You might ask yourself, well, how do I know that this compound is this drug and this drug? Well, we tap into that vibration. Okay, we use instruments that we know that that vibration of the atom is a certain frequency, and when we hit it with a certain frequency of energy, they absorb it, and we can run that information into the instrument to tell us to get a fingerprint of that particular compound. So there's a lot of tools that we have. Okay, when you heat ice or when you heat anything, what you're doing is you're picking up kinetic energy. That's energy that moves. Okay? Any movement energy. And if you have enough energy into the system, you finally move a solid into the liquid and liquid into the gas. It is all about energy. And this diagram kind of shows you all that. Okay. All right. Now, with respect to chemical changes, what I'm going to do here is we probably got a few more minutes. If the theory is, the question is, if we hit absolute zero, would a solid fall apart or would it just stop vibrating? The theory is it'll still be solid, and but it will stop vibrating. Okay. The question is, would it just fall apart? Interesting point, because now it's not interacting with its neighbor, and that's what's holding it together. So I don't know the answer to that part, but I do know that theory shows that would predict, I should say, that the atoms will stop vibrating. Now, there's an interesting aspect about going down to that temperature. Physical properties completely change. There's a whole new world down there as far as properties of compounds. All right, good question. Chemical changes. We change the molecule completely. We totally break apart, make something new. Okay, totally new. But it's still that particular element. It's just in a different form. Okay. Now, how could I demonstrate that? Well, one way to demonstrate that, and I'll leave it at this, is where'd it go? Where'd it go? Bear with me. I need to pull it up here real quick. Um, Apologies, can't find it. Hmm. I'll have to dig it up. I have to dig it up, but I was trying to demonstrate. So, um, chemical reactions. I got 5 more minutes here, and we'll call it a day here. Basically, the starting material is totally destroyed, and we have a new substance with totally different properties, but the atoms are still there. Here's a concept that sometimes is difficult to grasp when it comes to chemistry. If I start off with carbon, let's say carbon in the form of some tissue, it's incorporated in some tissue, and throughout the metabolism of a person, it gets converted to carbon dioxide, and then I exhale it. It's still carbon. It's just in a different form. Okay, still carbon. Now, a good example of a chemical change that we're all familiar with is a combustion reaction. Here's my future car sitting there. Yeah, they're different color though. All right, so you see the reaction bottom left-hand corner? It says CXHX. What that is a general formula. X has a number, okay? The lowest number for carbon is 1, and the lowest for hydrogen is 4. So that's methane. The point here is it's made up of nothing but carbon and hydrogen. Those are called hydrocarbons. Anytime I burn something, I need oxygen. So you notice here's my reaction arrow. To the left are my reactants. So I have a hydrocarbon plus oxygen. For Chem 130, okay, I repeat that. For Chem 130, when you burn a hydrocarbon, the only products you will get is carbon dioxide and water. Okay. Yes, in the real world, if you inhale that exhaust of your vehicle, you're gonna risk getting some carbon monoxide poisoning. Okay, that's because the efficiency of our engines is not too good, probably about 20-30% efficient. And therefore, when we burn oxygen or burn hydrocarbons, one of the products we get is carbon monoxide. But for Chem 130, for hydrocarbons that you burn under combustion, you get carbon dioxide and water. Notice you have completely changed the material. You started with a hydrocarbon, CH, started with oxygen, and the products now that you have is carbon dioxide and water. Totally different from where you started off. That is a chemical reaction, okay? Chemical reaction. And so how do we, I'll stop it right here. It's our last two. What are some indicators of that a chemical reaction happened? Well, if it burns, that's a good indication that hey, we got a chemical reaction. Cooking, every time you cook, a lot of people don't think about this, anything you cook is a chemical reaction. You have changed the structure. You fry an egg, you totally changed it. It's no longer an egg. It's a fried egg or a scrambled egg. It totally changed everything, okay? Rusting, good indication that a reaction proceeds. Sometimes a reaction, you see bubbles, okay? And without giving off heat. For example, would be Alka-Seltzer tablets. Alka-Seltzer tablets, it kind of, it's mind-boggling that they put that in there because from a medicinal standpoint, carbon dioxide, to my knowledge, does not have any medicinal value. So what happens in that tablet, they put a little bit of citric acid and a little bit of sodium bicarb. And then when you dump it in water, they dissolve. And guess what? They react with each other. It's like taking vinegar and baking soda, do that in the kitchen. You'll see it boiling. Well, the same thing happens with carbon dioxide in the tablet Alka-Seltzer. So it bubbles. Okay, so that's a good indication that a reaction proceeds. All right. Formation of a solid. You might put two chemicals that are colorless and clear and put them together and form a solid material. That's a good indication. Okay. Release of heat. You go to, right now, I know everybody's all sore and tired from sitting here. Go to the pharmacy, buy yourself a cold pack or a hot pack. Guess what? When you take them, you smack them, you give off heat, you give off cold. It gets cold, I should say. That's an indication of a chemical reaction. Or a light. These glow sticks, when you take the glow stick and you crack them, two reactants react. You get light that's being emitted. That's an indication that a reaction proceeded. Or color, it may change color. Blue color, yellow color, or an odor may observe. A lot of the mints that you like, wintergreen, banana oil, those are compounds that are made from materials that don't smell very good by themselves, but when they come together to form these type of compounds, they smell good, and that's a good indication that you made a reaction. Or the other way is they smell bad. Okay, so let's stop it here. Okay, let me verify. Madison Davis, did you show up? Are you here? Or it's probably gone, huh? Okay. All right, so let's stop it here. Would be chapter 21. Page, slide 21. Okay. Any questions, comments? I know everybody's tired. Thankfully, it's only once a week, okay? Once a week. So let me stop the